In comparison to mathematics, speciality of science is that science compares its results with observations or visible events. But if you see content of science, inside science we use many things which are themselves not visible. For example, maybe energy or mass in physics, or electric charge in physics, or outside physics in social sciences you can say humanity. We can see human being, but we cannot see humanity by our eyes. But we use in science these concepts and things, and we believe in them. And the reason for belief is that even if they are themselves not visible, they are related with visible, and it is because of their relation with visible that we believe in them as scientific statements or scientific concept or scientific things. They are included in science because of this relation. Now, relation between statement, if it is proved like mathematics, this forms logic. Okay, that can be, if you ask me definition of logic, then I would say that. So these relations are proved as mathematics, and they apply to visible and invisible things both, and they connect visible and invisible, they provide visible invisible relationship, which I'm talking about. Okay, and then in this lecture, I have to introduce some terminology related to logic. There is input and output, and the inputs are premises, and outputs are called conclusions. And and then another relation is that is logic itself science or not? And the answer is that logic is not a description or claim about things how they go. So logic itself is not science, because logic should be used. So mathematics is a different branch, but logic, where to put, in which subject to put logic in, and that the answer could be only philosophy. Perhaps science is conditioned by, science has to fulfill logic, and but it's not only logic. Science has to fulfill its coherence or consistency with observation as well. Science has something relation with observation, otherwise science would become logic, and but logic and science are two different things, and the distinction is because of science has consistency with observation, or kind of relationship with observation. If you want to know the word coherence, I have inside the lecture to tell you what coherence means. Okay, now I start actual lecture, and then I said about invisible and visible things, and about invisible thing here in this picture. Invisible is like, for example, gravitational energy, or you can say gravitational force. That's invisible, and we believe in gravitational energy or gravitational force because gravitational energy is related to different positions of something, and position we can see. So something which is not visible, which we cannot see, energy or gravitational force, that is related to positions. So that relation is essential to define science. Another thing could be charge is not visible, but it's related with many working of many machines, which you can see, machines which use electric charge and so on. So it's a relation. Now pay attention to the word relation, because this relation of invisible things with our visible, but with our observations, justify our belief in invisible things. So the relations are very important. They give you belief or knowledge of invisible things, even if you cannot directly see them. And it's essential to point out that the relations, or the rules of relations, they are valid for visible and invisible both. For example, a rule is 2 plus 3 equal to 5. I've taken it from mathematics, but mathematics and logic are related, and I have to clearly point out in a coming slide, but for the moment you just take it. If you don't know the word logic, and for the moment you say mathematics, and then I tell you the relation between logic and mathematics. For example, if for you using your previous knowledge, I have selected mathematics rather than logic. So mathematics says 2 plus 3 equal to 5. And that is also, by the way, a proved relation between 2, 3 and 5 and 2 plus 3 and 5. So it's proved relation between statements. And that can be used for visible things. You can say 2 tables plus 3 tables make 5 tables. And it can be used for invisible things as well. You can say two charges plus 3 charges, or maybe 2 energies and 3 energies make 5 energies, and 2 charges and 3 charges make 5 charges. Or you can say even social sciences, ideas, 2 ideas plus 3 ideas make 5 ideas, or anything, even about your feeling. So the rules of logic apply everywhere. So, but if you are still worried about the word logic, I have given example of mathematics. So if logic is a new word for you, then I specifically, I don't know onward, I don't rely on mathematics. No, I introduce logic per se itself. And I start with the Encyclopedia Britannica definition of logic in its entry called logic. Britannica says that the logic is a study of correct reasoning, especially at it involves the drawing of inferences. Inferences mean you draw results, you derive results. An inference or result is a rule-governed step from one or more preposition called premises, that is input, to a new preposition which is called conclusion, that namely output. So it's a rule that gives you output if you give input. And I have to point out, this rule is not a scientific rule, it's not what is obeyed. This rule is what should be obeyed. So it's a different. It's not a descriptive, but it's normative. That means the rules of logic or mathematics related statement they are proved and they should be used. So their argument is not only that they are used. What we do and which choices we make, that's a subject of psychology. But logic is not psychology. It's not about some people make this choice or not. Everyone should do it. So that should makes it something different to psychology, different to science. And if it is mathematics, is a special subject. But logic is not mathematics, and logic is not science. Science changes, logic should not change. So it should be something special. And I again, before telling you where the speciality lies, in which subject logic is taught, I point out that again I re-emphasize this word should. That logic should be obeyed. For example, this is mathematics is 2 plus 3 equal to 5. It's not that if you have to use 2 plus 3 equal to 5, so before that you ask psychologists that how many people believe in or how many people do not believe in. You think it's not needed. They should believe in it. So this is another example of should. So that means if it is should, it's not mathematics. It's not mathematics, but it's not science as well. So in which subject it is? So the answer is that logic, Encyclopedia Britannica says that logic is one of the 4 major branches of philosophy. So if anyone is still thinking that why philosophy is needed in this age of science, and someone may say that science and mathematics are sufficient, but it's not. We need science, mathematics, and for example logic. And not every training of logic is made in mathematics. So we need a subject different to both, and that is philosophy takes logic. Okay, that is one role of philosophy. Anyway, but coming back to the topic of what logic is, and the answer I told you, the logic is proved relation between statements, I said, and now I clarify. Relations mean assumed truth. It's not truth, it is assumed truth. And I have to tell you what assumed means. I have emphasized on that word. And the first use of logic in books, which we know, or at least what I know, is dates back to Aristotle, some 2,400 years ago. And he wrote it in his book of metaphysics, but today we teach it in logic. Anyway, the rule is that that if you have assumed, you learn the word assume as that. I'll give you examples. You have assumed that a rule is valid for a set. Whether it's actually valid or not, it's a different question. If you have assumed that it's valid, then you have to accept that it is valid for its part. The relationship from full to part, the relation is proved, and the relation is logic. For example, if you have assumed that all men are mortal, even if you don't know what the word mortal means, but see the structure, all, something is said about the set, all. And if you are told that this thing is a part of set, means set is all men and Socrates is a man, even if you don't know who Socrates is, you should conclude that Socrates is mortal, because the rule which is valid for all is valid for Socrates. So this means if all are mortal, Socrates is also mortal. This connection is proved. And first I saw symbolically, and the symbols may be familiar to you through set theory, and set theory is part of mathematics. But I indicate later clearly that mathematics and logic are related. So it's nothing wrong with explaining a logic concept through mathematics. They are related anyway. So whatever you call it, mathematics or logic, what I have to teach you is that if your input is, technical input is called premise, and the major is what is about set. Set is the major, that's the major. So what rule is for a larger set, and if you are told that this is a green, by green I mean it's subset. I have to give two colors, because you can think of that it was a green, but because it is part of this red, so any rule about red is applied on this green, and that makes it into this purple. Anyway, the result is output is conclusion. That's the name. And conclusion is applied for this, what was, I said green, but was the subset part, what is part I saw. Was part of there, and as part the rule is applied, and the result namely conclusion is that a rule is valid for part as well. Okay, you might be waiting for the word deductive, because it's common to say that what I'm calling it logic, very many people still call it deductive logic. But I have to reason to justify my claim, and that I can justify only in the next lecture. For the moment, you just be aware that I know the word deductive is used, and I have historical and other kind of reason as well, that the word qualifier deductive was needed maybe 100 years ago or no, but now it is clear Not that the things have changed, but the things have become more clear. It was ambiguity that the word deductive was there, but now ambiguity should be removed, and now we don't need the word deductive. And the reasons I have to tell you in next lecture, which is on inductive reasoning. So that's be aware of that, or don't care about that. You just remain using the word logic. Coming back to what logic is, and the answer has been logic relates input to output, and it relates even if your input is wrong in some sense, or wrong here I means eventually this is a course on philosophy of science. So when I say wrong, means it's not consistent with observation. I show two examples on this slide. First is where consistency with coherence is actually a term used in philosophy, and that's why I'm using the word coherent. Otherwise, you can take it as consistent. That means no logical clash. I've taken two examples. One is that which you may think that it is consistent. Something is your input or assumption is consistent with observation, but I have to point out that even if you think it's consistent with observation, you have not proved that it's consistent with observation. And that example could be that in the previous slide, when I said the major conclusion, the rule on the set is that all men are mortal. Think of that. Now I have to tell you which is Socrates and who is mortal. If Aristotle wrote this rule of major, minor, and conclusion, then Socrates was his teacher of teacher. So think of that. Suppose Aristotle wrote all that when Socrates was alive. And mortal means everyone has to die. But if Socrates is alive, one person has not died, how can you say everyone has to die? Well, you can say that, but you have to accept that this is not proved. It's not logically proved that all men have to die. So this is where observation, consistency of observation is. You think somehow or other it is there, but that is not proved. But you still assumed that all men have to die, and you applied it. And you used logic, and logic connected. And here you still think that something is technical about this, otherwise you think that it is consistent with observation that all men are mortal. It's only some philosophical terminology. Anyway, even if it is philosophical terminology, you have to learn this philosophical terminology in this course. All men are mortal is not proved. Although we have good words for that, that is verified, and there are other good words, but it is not proved. Okay, so, but next I show you example in which it's clear something is there, is not only not proved, something is even wrong. It's in the sense that it's not consistent with observation. But logic is not observation, logic is not science, logic is something, a relation, and the relation is still valid, even if it is, okay, think of it, even if it is your major premise, your inputs. Major premise means that your input statement about the set is that all cats have 7 legs. Because it's all, so logic has to be structure, not what the content. Because it's the rule is about all, is about set, and the rule about all cats is to be accepted for a part of set. Set was all cats, and a part is one cat, name is mono. So the rule which applies to all cats applies to mono as well. So the conclusion is that mono has 7 legs. So if you are worried that something I'm teaching you something wrong, that I tell you wrong is, what is wrong? The connection is not wrong, the logic is not wrong. The wrong is the initial rule. It's wrong in some other sense. It's not in the logical sense. As far as logic is concerned, you have to learn to make a distinction between, even if you have to praise with terminology. Okay, that's one of the lessons which is here. Previously I said, even if you have to praise that all men are mortal, you don't praise it by saying that this is proved. You look for an alternative terminology, which may be taught to you later, but you mentally be ready for it. That there can be an alternative to that. And similarly, if you have to see that, okay, if you have to say something is wrong, before previously I said something is right, and now you say if something is wrong, it's not that logically it's wrong. You have to be ready for learning other ways of saying things are wrong. So that's, yeah. Now, what was wrong with all cats have 7 legs, and what was right with all men are mortal is not a difference of logic. It's a difference of relation with observation. All men are mortal has a good relation with observation. It has a coherence, it's a consistency. And this course tell you where this consistency is available and where this consistency with observation. It's also a topic. This course is not limited to logic. It's not about relation between statement. We have to pass these comments as well. There is a difference between all men are mortal and all cats have 7 legs. The first one has coherence with observation, and all cats have 7 legs has no coherence with observation. So, and in science, this coherence is achieved, or some people say this coherence with observation should be achieved. Now, these are two different ways of explaining science itself. And the terminology is that, can you recall what is explanation of science? Science is first order explanation of observation, and this is explanation of explanation. That means the second order explanation, and second order explanation of observation is philosophy. So whatever you call is achieved in science or should be achieved in science, these are two philosophies. And in terminology, if you say is achieved in science, that is the descriptive philosophy of science, that tells you what we do in science. And if you say should, that tells you what we should do in science, that prescribes it. Like a medical doctor prescribes you medicine and you should use that medicine. So if you say this mode of working should be, must be used in science, that's prescriptive philosophy of science. But anyway, whatever, if it is any kind of explanation of science, then that is explanation of explanation, that is second order explanation of observation, and that is philosophy. Okay, before finishing it, before conclusion or something like that, I have to give you more practice in checking the relationship between input and output. And for that, I give you something like a test. You can stop the video if you want to get more time on it. But anyway, furthermore, I'm giving you some time. You check your understanding. If someone says that your input is major premise, the rule about a larger set is that many videos of philosophies are boring. I mean, there are many, so it's a big set. And another premise, which is another input, is that this is a video on philosophy. And someone says that my conclusion from these two inputs is that this video is boring. Now here, even if you think that statement 1, statement 2 and statement 3 is separately correct, but if you have to learn logic, then don't see what is truth and what is not truth. If you have to see logic, you say what is the relation correct. So even if you think that all three are correct or something correct or not, you see the relation. Is the relation correct? I have given you some time and you can stop and think more, but I have to continue telling. And the answer is not. Relation is, the concept is not that whether all three are separately true or false. That you can have any opinion. But here, you cannot have an opinion. You should accept that the relation is broken. And the reason is that the many videos are boring. But about this, you can't be sure. Is that in many? Maybe it's not in many. So in that case, you cannot say that logical result that it's boring. Even if you want to say it's boring, but it's not logical result. And there the terminology is learning logic, not gathering your opinions. But logic you should be able to say. So the logic is connection, and that is broken here. Even if whatever you think about separately about these things, but you should know their relation is broken. So logic is violated here. Okay, I have to clarify something before finishing. That is the relation between logic and mathematics. So much so that in the early part of this lecture, when I had not introduced the term logic, I started talking about logic by the example of 2 plus 3 equal to 5. That's mathematics. So what is mathematics and logic in the same lecture? And the answer is, I think Bertrand Russell has written a big book on that, that even mathematics is a symbolic logic. Anyway, these two are related, and to show the relationship, I can ask you a question. The symbol L is 3 centimeter and A is L square. So can you see the usage of terminology, input and output, namely premise and conclusion here? If so, can you see what is input and what is output? Can you recognize any output or not? I'll give you time, but can't give you more time. Both are inputs, and the question is, input is premise, and one is the major premise and one is the minor premise. So that's next question to you. What is major premise and what is minor premise? What is the rule for all and what is part? And what is output? Is output there? So I've asked you 3 questions and I give you time. You can stop and take more time for thinking, but I have to give you answer. And this is that it's not necessary that major premise is written first. Logically it should be major, in that it should be a rule about a bigger set. And the bigger set is all values of L. So what is the rule about all values of L is a major premise. There is a particular value of L which is some part of that, that's a minor premise, and the conclusion output was not written there, and that is now written. I have applied this rule to this part, and that means in place of L I write 3 centimeter, and 3 centimeter square is 9 centimeter square, and that is conclusion. So you can see that mathematics can also be written in the language of logic. So if I give you 2 plus 3 equal to 5, that could be written that can be taken as an example of math, of logic as well. So my whole lecture has been on logic, even if you think that initially it was on mathematics and later I switched to logic. It's not. I can say that throughout the lecture I have been talking about logic. Okay, one thing before finishing, I have to point out that major premise is a rule, and the technical term in philosophy by the rule is, and the rule is practically recognized by the word all, but it's not only all. Otherwise, we could have said all statement. You know, sometimes the words used are different. Sometimes all, sometimes each, sometimes every, sometimes any. But if the meaning is about the whole set or all, that's a universal statement. This and a major premise is a universal statement. So that you learn, and then I finish it with the conclusion that relation proved, like mathematics is proved. Relation between statement which you have assumed, whether they are actually truth or not, that's not the question here. If you have assumed to be truth, the relation between them, the proved relationship between them is logic, and that is not in any other subject. It perhaps can only be taught in philosophy, and that becomes one example why philosophy is needed as a separate discipline, even if this age of science and mathematics. And here I also emphasize in the second half of the lecture on the word should, to emphasize that logic is not science, because scientific statements do not use the word should. Scientific statements are true, are taken to be true. They describe, but logic should be taken to be true. It's not a choice that we say how many people accept it. They should accept it. And that's logic does not, if it is correct, that it does not is not revised because of new observations. Science is revised, changed because of new observation, but not logic. And I taught you terminology of major, minor, premise, and conclusion. And thank you for watching. And I think that's all. Okay, now something remains. That science is a combination of logic and I said that comparison with and in comparison, if it is correct science, then comparison results in consistency with observation. So that is about science. So maybe you should keep reminding ourselves what is the role of each lecture in science. So that's also, I said. Anyway, that's all, and thank you for watching it.